Assalamualaikum. Hi everyone. I am Teacher Shika and welcome to Learn Physics in 15 minutes. So today we will continue our lesson in chapter 2, Force and Motion 1, where we are focused on the fifth subtopic, momentum. Hold on a second. Before we start our class, I will tell you the learning outcome of today's lesson. I hope at the end of this class, you guys will be able to apply the principle of conservation of momentum in collision and also explosion. Wait, what are those things? No worry, kids. I will explain to you soon. Okay, here I share with you guys the situation that happen in our daily life that we can relate with today's lesson. For situation 1, as we can see, there is a pedestrian was hit by a bicycle. What do you guys think will happen to her? I think she would just slightly injured. Next, we move on to the situation 2. It shows a man who is also a pedestrian was hit by a car. Hence, what will happen to him? Did he okay? Or did he hurt? I think he might suffer major injuries. So, why the result in situation 1 and situation 2 are different? How can we explain about the difference of these two situations? Now I will tell you a secret. Shh. There is a concept in physics which is called momentum. It can explain why those situations can happen. But what is momentum? Momentum is the product of the mass of an object and its velocity. Therefore, the formula of momentum is P equal to mv. We denote momentum by P. Why we are not using m? Since we know m is the initial consonant of momentum. It is because we have used m. We use m to denote the mass. So, m is the mass of the object and v is the velocity of the object. Wait, what about the unit? What is the unit of momentum? And how can we calculate the SI unit of momentum? Don't worry about that. Here I share you the trick. Since we know the SI unit of mass is kilogram and the SI unit of velocity is meter per second, hence we know the SI unit of momentum is kilogram meter per second. Momentum is a vector quantity because it has both magnitude and also direction. Since momentum has a direction, it can be used to predict the resulting direction and speed of motion of object after they collide. So, in order to explain the two situations before on why the condition of the pedestrian in situation 2 is worse than the condition of the pedestrian in situation 1, we will calculate the momentum of both situations to show you the reason. In situation 1, the mass of the bicycle, including the cyclist, is 50 kg, while the velocity of the bicycle is 10 meters per second. Here, the momentum of the bicycle is 1,500 kg/meter per second. In situation 2, the mass of the whole car is 1,500 kg and the velocity of the car is also 10 meters per second, same with the velocity of the bicycle. So, do you think the momentum of the car will be the same as momentum of the bicycle? The answer is no. The momentum of the car will be 15,000 kg/meter per second. It is because the mass of the car is greater than the mass of the bicycle. This shows, although they have the same velocity, but their mass is also playing an important role in determining the momentum. Hence, the momentum of car is greater than the momentum of bicycle. Therefore, the pedestrian will suffer severe injury when he was hit by car, while the pedestrian will just got minor injuries when she was hit by bicycle. So, we are done with our revision on what is momentum. Now, we will continue with the principle of conservation of momentum. In physics, the term conservation refers to something which doesn't change. This means that the variable in an equation which represents a conserved quantity is constant over time. So, the principle of conservation of momentum is the total of momentum of a system remain unchanged or remain the same in the absence of an external force. To make it simple and easy to understand, it means the total momentum before collision is equal to the total momentum after collision. As stated in the learning outcome, there are two types of momentum, which are collision and also explosion. How can we apply the principle of conservation of momentum in elastic collision? First of all, we need to know the meaning of elastic collision. So, the elastic collision is any collision in which the collide objects get separated after the collision. For an example, here is a ball with M1 and here is the ball with M2. The M1 ball is moving to the right with the velocity of u1 and the M2 ball is moving with the velocity of u2 to the same direction. Since the M1 is faster, so it will collide with M2. Then, what will happen to the balls after the collision? The M1 ball will move slower with the velocity of v1, while the M2 ball will move faster with the velocity of v2. This shows that the balls are independent after the collision. As we know that momentum is the product of mass and velocity, so the momentum of ball 1 is m1 u1 and for the ball 2 is m2 u2. The principle of conservation of momentum is the total momentum before the collision. So it means it is the addition of both momentum before the collision. Therefore, the total momentum after collision will be m1 v1 plus with m2 v2. Hence, the total momentum before is equal to the total momentum after. Next, what about the inelastic collision? What is the difference between elastic and inelastic? The inelastic collision is any collisions in which the collide objects stick together after the collision. From the statement, we know that the situation before the collision is same as elastic collision. So, the total momentum before collision is m1 u1 plus m2 u2. Then, what will happen next to the balls? They are attached together and move at the same velocity. They share the velocity as they move together. This indicates that the balls are not separated as its condition during elastic collision. Hence, the total momentum after the collision is the combination of m1 and m2 of the ball multiplied with v. Therefore, this is how the principle of conservation of momentum is applied to inelastic collision. Yay! Finally, we are in the last section, the explosion. What is explosion? Explosion refers to a situation where the objects at rest break up into two or more parts. Shooting a gun is an example of explosion. Before shoot, the gun and the bullet are at rest, which means U1 and U2 equal to 0. Therefore, the total momentum before collision is 0. During shoot, the gun moves backward with the velocity of v1, while the bullet moves forward with the velocity of v2. So, the total momentum after the collision is m1 v1 plus m2 v2. Explosion is a closed system which does not involve external forces. As such, total momentum is also conserved in explosion. In order to verify that you guys have achieved the learning outcome or not, here are some practice to test your input. Please refer to the screen for the questions. I hope you guys managed to answer all the questions given. Later, let's discuss the answer together. Okay, first, state the type of momentum involved based on the situation given. The answer is inelastic collision. It is because they stick together after the collision. Next, what is the velocity of both trolleys after the collision? Do you guys remember the formula for the inelastic collision? Here it is. Then, you need to substitute all the information given in the diagram into the formula. Hence, the final velocity is 1.2 meter per second. Here is another practice for you. Based on the question, we can identify that it is related to explosion momentum. Why did I say so? The reason is because the situation shows that the gun and the bullet break up into two parts after the fire. Let's list out all the information first. So, here is the information for the gun, and here is the information for the bullet. In order to show you that the explosion can be applied in the principle of conservation of momentum, we will use this formula. Apply all the information into the formula, then we will get V1 equal to negative 5.33 meter per second. The negative sign signifies that the direction of the gun is opposite to the direction of the bullet. So that's it. That's all for today. Hope you enjoyed the video. See you next time. Bye.